Good evening, sir.
Yeah, ma'am. Good evening. Good evening to all.
Good evening, sir.
Yeah.
Good evening, sir.
Yeah, Lakshmi. Where are you joining from, man? Where's yours? Ajay. Where is Ajay? Ajay is there?
Yes,
All right.
sir. Yes, sir. He's joining from here.
Okay, ma'am. All right. We'll continue one or two questions and then go to the next topic. Yesterday, we learned Faraday's first law. In detail, we learned. And I told you the mathematical representation of Faraday's first law. The Faraday's first law is given by the formula W is equal to Z into I into T. W is directly proportional to quantity of charge passed, Q. Q is nothing but I into T. If you remove the proportionality sign, we give a proportionality constant. This is called as electrochemical equivalent, abbreviated as ECE. And the unit for Z, you should remember, it is gram per coulomb. Because we know that Z is given by the formula equivalent weight by 96,500. So equivalent weight is expressed in terms of grams, and this is in terms of coulombs. So gram per coulomb is the unit for electrochemical equivalent. One or two problems, and then we'll go to the next part of the topic. Now, when 0.1 mole of MnO4 minus is oxidized, the quantity of electricity required to completely oxidize MnO4 minus to MnO4 minus is, they're asking the quantity of electricity. Now, in order to understand this problem, firstly, we will try to understand the reaction. MnO4 minus is oxidized to MnO4 minus. Here, the oxidation number of manganese is +6. Here, the oxidation number of manganese is +7. So, in order to oxidize 1 mole of MnO4 minus to 1 mole of MnO4 minus, the number of electron required is 1 mole. So, how many mole of electron is lost? From +6 to +7, there's increase in charge by only 1 electron. That means if I take this 1 mole, we require 1 mole of electron. So as per the equation, maybe we can write for 1 mole of MnO4 minus, 1 mole of electron, charge carried by 1 mole of electron is what? 1 Faraday. So I can write it as what? 1 Faraday here. 1 Faraday of electricity is required. For 1 mole of MnO4 minus, 1 Faraday, because as per the reaction, we understand that increase in charge is from +6 to +7. The electron lost for oxidation is only 1 electron. So if you take 1 mole of this, 1 mole of electron is lost. But what's the question they're asking? When 0.1 mole of MnO4 minus. So therefore, for 0.1 mole, what is the amount of electricity required? It will be 0.1 into 1 divided by 1. That is nothing but maybe 1 Faraday is how many coulombs? 96,500. This is nothing, 0.1. 0.1 will be how much? 96,550, 9,650 coulombs. Because we know that 1 Faraday is 96,500 coulombs. Therefore, 0.1 Faraday will be equal to what? 9650 coulombs, 9,650 coulombs. Therefore, the answer for this question is option C. Did you understand this one? Do you understand this working?
Yes, sir.
Yes, sir.
The next question. A 5 ampere current is passed. A 5 ampere current is passed through a solution of zinc sulfate for 40 minutes. The amount of zinc deposited at cathode is. the amount of zinc deposited at cathode is. Now you should remember the atomic mass of zinc is not atomic mass. The equivalent, yeah, the atomic mass of zinc they've not given you. The Z value, equivalent mass of zinc is 63.5739. Equivalent weight of zinc, you should remember, it is 65.39. Equivalent weight of zinc. Now the question is, W is equal to Z into I into T. Z, you know, it is equivalent mass by 96,500. That is 65.39 divided by 96,500. Current, they have given 5 amperes. It is 5. Time, they have given 40 minutes. Time always has to be taken in seconds. So it will be 40 into need to remember the equivalent mass of zinc. The equivalent mass of zinc is 65.39. So equivalent mass 65.39 divided by 96,500 will give you a Z value. Multiply by the current, they've given 5 amperes, and time, it is 40 minutes. 40 minutes is nothing but 40 into 60 seconds, because time always have to be taken in what, seconds. All right. The next question: how much metal will be deposited when a current of 12 amperes with a 75% efficiency, is passed through the cell for 3 hours? Now we know the formula, W is equal to Z into I into T. And for efficiency, we gave one relation. If you remember, it was given by eta. So Z, for what's that they've given Z? They're asking how much of metal will be deposited when a current of 12 amperes with 75% efficiency. Z they've given you here directly. 4 into 10 to the power minus 4. Electrochemical equivalent they've given you 4 into 10 to the power minus 4. Current they've given 12 amperes. Time, it is 3 hours. 3 into 60. Each hour contains 60 minutes, and each minute is 60 seconds. Therefore, 3 into 60 into 60. And efficiency, they've given 75%. That means 75 divided by 100. Percentage, when we say it is with respect to 100, therefore, it is 75 divided by 100. So on simplification, we will get the answer to be 38.8 grams. Did you understand the terminology now, efficiency here? Yes?
Yes, sir.
Yes. The next question. See, if you're not able to follow, please ask me. Dhanalakshmi, follow the previous problem?
Yes,
Ritika?
sir.
Ritika is there. 2 Faradays of electricity, 2 Faradays of electricity are passed through a solution of copper sulfate. The mass of copper deposited at cathode is, atomic mass of copper is 63.5. They say 2 Faraday of electricity is passed through a solution of copper sulfate. The mass of copper deposited at cathode is. Now copper sulfate, copper 2 plus and SO4 2 minus. Copper sulfate will dissociate to form copper 2 plus and SO4 2 minus. The question is very clear. The mass of copper deposited at cathode. At cathode, what takes place? Reduction takes place. Cu2 plus will accept 2 electrons to form Cu. This is reduction. Gain of electron is called as reduction. Now, if you observe this equation carefully, 1 mole of copper 2 plus ions requires 2 Faraday current, so that you get 1 mole of copper metal. This is copper metal in neutral charge. This is copper 2 plus ions. So 1 mole of copper 2 plus ions requires 2 Faraday. And to get what? 1 mole of copper. The question is, 2 Faradays of electricity is passed through a solution of copper sulfate. The mass of copper deposited at cathode, atomic mass of copper is 63.5. So now you can observe this. 1 mole of copper 2 plus ion consumes 2 Faradays of charge. Therefore, you get 1 mole of copper. So this 1 mole of copper, the atomic mass of copper is 63.5. Therefore, the amount of copper deposited at cathode is 63.5. Answer is option D. Did you follow this?
Yes, sir.
Yes, sir.
If I ask you a question, instead of 2 Faraday, if I pass 1 Faraday current, what will be the amount of copper deposited?
So 63.5 divided by 2, sir.
Very good. 63.5 divided by 2. It's a half of this. Correct. The next question. The number of electrons delivered at cathode during electrolysis by a current of 1 ampere in 60 seconds is, the charge of an electron is 1.6 into 10 to the power minus 19. Now, Q is equal to I into T. Now, we know that the current, what they've given is 1 and time is for 60. So therefore, the charge Q is 60 coulombs. The charge, not 60 coulomb, yeah, 60 coulomb. Charge is what? 60 coulombs. Now, we know that 1.60 into 10 to the power minus 19 coulombs is nothing but charge of 1 electron. Therefore, 60 coulombs of charge will be giving you how many electrons? It's cross multiplication. Because we know the charge of an electron, they've given you 1.60 and 10 power minus 19. So 1.60 and 10 power minus 19 is charge carried by 1 electron. So 60 coulombs of charge will carry how many electrons? So it is 60 into 1 divided by 1.60 into 10 to the power minus
3.75 into
19.
10 power 20.
3.75 into 10 to the power
20.
20 electrons. Very good. 3.75 into 10 to the power 20 electrons. Therefore, the answer for this question is option C. All right, did you follow this? Both of you, all the people followed?
Yes, sir.
Yeah.
Yes,
Now,
sir.
Faraday's second law we are going to talk about. Faraday's second law. Now, what is this Faraday's second law? Now, just observe this illustration. Later, we will come to the definition part of it. Now, I take an electrochemical cell. In this, I have anode and cathode. I have anode and cathode. And it's connected to the power supply. And the electrolyte is sodium chloride. I have here, again, a different cell set up. Here it is copper sulfate, anode and cathode. The third one I'm using here, anode and cathode, and the electrolyte here is silver nitrate. Now, what we're doing is we are passing into different electrochemical cell 1 Faraday current. The common thing here is what? 1 Faraday. Now, different electrolytes, but the amount of current passed is same. Now, when we say amount of current passed is same, now sodium Na plus will get deposited at cathode here as sodium metal. Here, copper gets deposited here. And here, silver will get deposited. You know that at cathode, what happens? Reduction takes place, the metal gets deposited. Now, when I say sodium gets deposited here, the amount of sodium getting deposited, I tell 23 grams of sodium gets deposited. How many grams of sodium? 23 grams of sodium. Here, 31.75 grams of copper gets deposited. And here, 108 grams of silver gets deposited. Did you understand this illustration? We have taken different electrolytes and we're passing same amount of current. Into the same, into the different electrolytes, when you pass same amount of current, the metal gets deposited at cathode. In the first case, sodium gets deposited. The second case, copper. The third case, just silver. Sodium, how much it gets deposited? 23 grams. Copper, 31.75 grams. And silver, it's 108 grams. Can you tell me what is this Faraday's second law? Now, before we define Faraday's second law, What is the equivalent weight of sodium? How do I find the equivalent weight of sodium? Atomic weight divided by valency.
Valency, sir.
What's that? Yeah, atomic mass of sodium is how much? 23. What's the valency of
23.
sodium?
1,
Valency
sir.
of sodium?
Plus
1.
1.
So therefore it is 23. What is the equivalent weight of copper? Atomic mass of copper, yesterday we learned, I think it is 63.5. 63.5. What's the valency of copper?
2, sir.
2. So therefore it will be 31.75. Now what's the equivalent weight of silver? 108 is the atomic mass. What's the valence of silver? Yesterday we
1,
learned.
sir. 1.
1. Therefore, it is 108 grams. Now you can see the weights, what I've written here. This is nothing but equivalent weight of sodium. This is equivalent weight of copper. And this is nothing but equivalent weight of silver. You can identify that. Now Faraday's second law states that on passing same quantity of electricity into different electrolytes, on passing same quantity of electricity into different electrolytes, the amount of metal deposited or liberated at an electrode will be equal to its equivalent mass. Will be equal to what? Its equivalent mass. What is Faraday's second law? For the same quantity of electricity passed into what electrolyte? Different electrolytes. Now we are passing 1 Faraday current. Therefore, the amount of metal deposited will be equal to 1 gram equivalent weight of sodium. That's 23 grams. Here you're passing 1 Faraday current. The amount of copper deposited is 1 gram equivalent weight. That is 31.75. And here we are also passing 1 Faraday current. The amount of silver deposited is 1 gram equivalent weight. That's nothing but 108 grams. Now my question is, now if we pass 0.1 Faraday current in all the three, 0.1 Faraday current, what will be the amount of sodium getting deposited? It will be 2.3. Here it will be 3.175. Here it will be 10.8. Are you following this? Are you following?
Yes, sir.
Yeah. See, Faraday's second law states that when same quantity of electricity is passed through different electrolytes, the mass of different ions liberated at the electrodes are directly proportional to their chemical equivalents. That's nothing but what? Equivalent weights. So this is the definition of Faraday's second law. On passing same quantity of electricity into different electrolytes, the amount of substance deposited will be equal to its what? Equivalent weight. Now, this is the mathematical representation of Faraday's second law. What is that? W1 divided by W2 is equal to E1 divided by E2. What is W1? Weight of metal deposited at one cell divided by weight of metal deposited in the other cell will be equal to equivalent weight of the first cell divided by equivalent weight of second cell. Meaning, now if we take these two, this we will not consider now. This we will not consider. Now here we can write weight of, for this one I'm writing these two, weight of sodium deposited divided by weight of copper deposited will be equal to equivalent weight of sodium divided by equivalent weight of copper. Did you understand this formula? Did you understand this formula?
Yes, sir.
For this one, what will be, for these two, what will be the formula? Tell me for these two, copper and silver, what will be the formula for copper and silver? What will be the copper and silver formula for these two electrodes? If you take these two electrodes, what will be the formula? These two. So weight of copper,
The weight of copper divided by
weight of silver, that will be equal to equivalent weight of copper divided by equivalent weight of silver. All right. Now just observe this formula. The formula, what we're going to learn. We know that W is equal to Z into I into T. We know that W is equal to Z into I into T. So for W1, we write it as Z1 I into T. For W2, we write Z2 I into T. That will be equal to E1 by E2. Or this IT and IT will get cancelled. Z1 by Z2 is equal to E1 by E2. But this is the formula we'll be using to work out the problems. But you should remember, electrochemical equivalent of one metal divided by the electrochemical equivalent of the other metal will also be equivalent to their equivalent mass. Thus, electrochemical equivalent Z of an element is directly proportional to its equivalent weight. Z1 is directly proportional to E1, Z2 is directly proportional to E2. So this is the formula. So if you remove the proportionality sign, we give a proportionality constant, that is Faraday. E is equal to Z into F into Z. F is 96,500 coulomb. 1 Faraday is 96,500 coulomb. 1 Faraday is electric charge carried by 1 mole of electron. We learned it yesterday. Did you understand this so far?
Yes, sir.
So we'll try to work out some of the problems based on Faraday's second law today. Now, how do you identify or differentiate between Faraday's first law and second law? For Faraday's second law, remember the amount of electricity will be same. The amount of electricity will be same. Now, for same amount of electricity is passed through the solution of silver nitrate and HCl. Silver nitrate and HCl. If 1.08 grams of silver is obtained from silver nitrate solution, the amount of hydrogen liberated at STP will be. What's the amount of hydrogen liberated at STP? So what will be the formula we can write? Since they have given silver nitrate first, I can write weight of silver divided by weight of hydrogen is equal to equivalent weight of silver divided by equivalent weight of hydrogen. Can we write like this? No problem.
Yes,
Now, what's
sir.
the question they're asking? They're asking the amount of hydrogen. So therefore, the weight of hydrogen will be equal to what? Weight of hydrogen will be what? Weight of silver into equivalent weight of hydrogen divided by equivalent weight of silver. Now, what's the equivalent weight of silver they've given? They've given the weight of silver to be 1.08. What's the equivalent weight of hydrogen? Atomic mass of hydrogen. What's the equivalent weight of hydrogen? Atomic mass of hydrogen is 1. Valency of hydrogen is also 1. Therefore, equivalent weight of hydrogen will be what? 1. Right. So 1.08 into 1 divided by what is the equivalent weight of silver? What is the equivalent weight of silver?
So
Just now, 108. Very good. 108. So on simplification, the answer what we will get is 0.01 grams. The answer for this question is option C. Did you follow this?
Yes, sir.
Yeah. Now I want you to continue with this. This is a question which was asked in the previous papers or the material. Okay. Now they have given the mass, so you calculate it. If I would have asked you to calculate the volume of hydrogen, how do you do it? What's the further continuation? What's the further continuation? What's the further continuation? Tell me. Can we write like this? I'm writing it here. Volume, please pay attention. Now for this, we know that 1 mole of hydrogen, that is 2 grams, occupies 22,400 centimeter cube. That's called as molar volume. Volume occupied by 1 mole of a gas is 22,400 centimeter cube. But we know the equivalent mass of hydrogen is what? 1. We found out here. So that means 1 gram of, 1 mole of hydrogen is 2 grams. So 1 gram of hydrogen, 1 gram of hydrogen will occupy what volume? Half of it, 11,200 centimeter cube. Understood or not?
Yes, sir.
If that's the case, now 0.01 gram of hydrogen will give how much? What's the volume of it? This is the question. So it will be 0.01 into 11,200 divided by 1. So it will be what? 112 centimeter cube. The volume occupied by 0.01 gram of hydrogen is 111 centimeter cube. Did you follow this?
Yes, sir.
Yes, sir.
Yes. The next question. An electric current is passed through silver nitrate solution using silver electrodes. 15.28 grams of silver is deposited. So weight of silver deposited is equal to 15.28 grams. At cathode, what will be the weight of copper deposited on cathode if the same amount of electricity is passed through copper sulfate solution? So weight of copper we are supposed to find. So what will be the formula now? Weight of copper divided by weight of silver will be equal to equivalent weight of copper divided by equivalent weight of silver. So what's that now? Weight of copper will be what? Equivalent weight of copper into weight of silver divided by equivalent weight of silver. What's the equivalent weight of copper?
So 31.75.
31.75. What's the weight of silver? They've given you as 15.28 divided by equivalent mass of silver is 108. On simplification, what's the answer you will get? The answer you will get is around 4.49 grams. The answer we will get around is 4.49 grams. Hence, the answer for this question is option A. So please remember, don't few of them for equivalent mass of copper, equivalent mass of silver, equivalent mass of zinc. These three you remember. Otherwise, they should give it in the question in some of the competitive exams. They will give it the question. The next problem. An electric charge of 5 Faraday is passed through 3 electrolytes: silver nitrate, copper sulfate, and ferric chloride solution. The grams of metal liberated at cathode will be the grams of each metal liberated at cathode will be. In the first case, Ag plus silver nitrate will give you what? Ag plus. Ag plus will accept electron to form Ag. This is reduction. 1 mole of electron is nothing but 1 Faraday current. 1 Faraday current. Now, in case of copper 2 plus accepts 2 moles of electron to give copper. That means 2 moles of electron is 2 Faraday current. Likewise, Fe3 plus will accept 3 moles of electron and reduce to Fe. So 3 moles of electrons here, that is 3 Faraday current. Now they're asking what's the grams of what? Each metal liberated. So grams of each metal, grams of silver liberated will be, equivalent mass of silver is 108. And the valency of silver is what? 1. And they are passing how much moles of current? 5. So multiply by 5. That will be equal to 540 grams. So similarly, what will be the grams of copper liberated? Equivalent mass of copper, I know it's 31.75 into 5. 31.75 into 5 is 158.75. Likewise, the third one is iron. I don't know the equivalent mass of iron. All right. So grams of iron liberated is atomic mass of iron is 56. Remember, atomic mass of iron is 56. What's the valency of iron? Fe3 plus, it is 3 into 5 because 5 Faraday current we are passing. So the amount of iron liberated will be 93.3 grams. The answer for this question is option D. Look at the question and just see whether you can follow what I'm telling, what I had written. Followed?
Yes, sir.
Yes. Others followed? Are you there? All right. The next question. If 54 grams of silver is deposited during electrolysis, if 54 grams is deposited during electrolysis reaction, how much of aluminum will be deposited by passing by same amount of current? By same amount of current. It is Faraday's second law. 1 Faraday deposits 108 grams of silver. Because we know that Ag plus electron gives you Ag. So 1 mole of electron is required for the reduction of 1 mole of Ag plus ions to Ag. So if that's the case, 54 grams of silver requires how much of current? First, this is the first part of the question. How much of current? 54 into 1 divided by 108, it is half of Faraday or 0.5 Faraday. 0.5 Faraday. See here, 54 grams of copper is deposited during electrolysis reaction. Now the question is, how much of aluminum will be deposited? So not for the same amount of current. So from silver, we found out how much of charge is passed. Now using this, we are supposed to do the second part of the question. Aluminum valency is 3. 1 mole of aluminum requires 3 moles of electrons to get reduced. 1 mole of aluminum ion requires 3 Faraday current. 3 Faraday current. So when I say 1 mole of aluminum ion, that is 27 grams, requires 3 Faraday current. But from the first part of the question, we know we're passing 0.5 Faraday. So when we pass 0.5 Faraday, how much of aluminum will get deposited? It will be 27 into 0.5 divided by 3. It will be 4.5 grams. This will be 9. 9 divided by 9 into 0.5 will be 4.5 grams. The answer for this question is option B. Did you understand this? Did you understand this?
Yes, sir.
The next question. 4.5 grams of aluminum. It's almost, okay, this is different. 4.5 grams of aluminum, atomic mass is 27, is deposited at cathode from Al3 plus solution by certain quantity of electric charge. The volume of hydrogen produced at STP from H plus ions means acid, in a solution of same quantity of electric charge will be, the same problem we worked out. Weight of aluminum divided by weight of hydrogen is equal to equivalent weight of aluminum divided by equivalent weight of hydrogen. Now, firstly, we will calculate the weight of hydrogen. Weight of hydrogen will be what now? Weight of aluminum into equivalent weight of hydrogen divided by equivalent weight of aluminum. What is the weight of aluminum? It's 27 grams. Atomic mass is 27. No, not 27. It's 4.5. Sorry. It is 4.5. Into what's the equivalent mass of hydrogen? We know it's 1. What's the equivalent weight of aluminum? Equivalent weight of aluminum is 9. So on simplification, the mass of hydrogen will be around 0.5 grams. 0.5 grams. Now tell me, they are given in liters. They're asking you the volume of hydrogen. So I can say 1 gram of hydrogen occupies 11,200 centimeter cube. In the first problem I worked, equivalent mass of hydrogen is 1. So here 0.5 we got. So 0.5 gram of hydrogen will occupy what volume? 0.5 into 11,200 divided by 1. It will be 5,600 centimeter cube. That is 5.6 liters. So the answer for this question is option D. Followed?
Yes, sir.
Yeah.
Yes, sir.
The next problem. The weight of silver is, atomic weight is 108. The weight of silver displaced by the quantity of electricity which it displaces 5,600 ml of oxygen at STP will be. Oxygen at STP will be. What's the answer for this question? Now, we know that since 22,400 ml volume, 22,400 volume is occupied by 1 mole of oxygen. This is nothing but molar volume, oxygen at STP. So volume occupied by 1 mole of oxygen is 22,400 ml. Therefore, they've given 5,600 ml or volume will be occupied by how many moles? It'll be 5,600 into 1 divided by 22,400. It'll be 0.25 moles. 0.25 mole. 1 by 4, that's nothing but 0.25 moles. Therefore, what will be the weight of oxygen? 1 mole of oxygen weighs 32 grams. 0.25 moles will be how much? 0.25 into 32. That will be equal to 8 grams. So weight of oxygen is what? 8 grams. Because in this problem, they have not given you the weight of oxygen directly. They're asking you to calculate now weight of silver. Now weight of silver divided by weight of oxygen is equal to equivalent weight of silver divided by equivalent weight of oxygen. So therefore, what will be weight of silver? Weight of silver will be equal to equivalent weight of silver into weight of oxygen divided by equivalent weight of oxygen. See, cross multiply this, that's all. What is the equivalent mass of silver? We know it's 108. What is the equivalent mass of oxygen? What is the equivalent mass of, not weight of oxygen is 32. What is the equivalent mass of oxygen? Tell me what is the equivalent mass of oxygen? Equivalent
16?
mass. Huh? No.
16?
Equivalent mass of oxygen is not 16. What's the atomic mass of oxygen? Atomic mass of oxygen is 16. What's the valency of oxygen? It is 2. So 8 is the equivalent mass. Because we write it as O2 minus, if you remember. Atomic mass of oxygen is 16. And since we have valency 2 minus, it will be 16 by 2, it's 8. So equivalent mass of oxygen is 8. So when you simplify this, again, the answer what we are supposed to get. Answer we are supposed to get is, no, where's that? Where's that? What's the answer you're supposed to get? I'm simplifying it right, no? What's the question? Somewhere I missed the question. No, it's correct only. Correct only. What's the answer I'm getting? No, I should get some. What's the answer? Somewhere it's wrong. Weight equivalent mass of silver is 818. Oh, see, it's also correct. Weight of oxygen is 32. Weight of oxygen is 32 allama. It's 8, no? Weight of oxygen is 8 here. Sorry. See here? I've taken 32 here. Weight of oxygen we found to be 8. It's 8 here. And equivalent mass of oxygen is also 8. So therefore this 8 and 8 gets cancelled. It's 108 grams. Answer for this question is option D. Followed with this?
Yes, sir.
Yeah. Now, we have worked more number of problems also on Faraday's first law and second law. I think so. There is no confusion with Faraday's first law and second law. Right? No. Now, Faraday's laws for gaseous electrolytic products. It's not there in the syllabus, but we'll try to understand this formula. Faraday's laws for gaseous electrolytic products. For gases, we use V is equal to IT into VE divided by 96,500. V is volume of gas evolved at STP. V is equivalent volume. What is this equivalent volume? That's equal to volume of gas evolved at an electrode at STP by passing 1 Faraday curve charge. On passing 96,500 coulombs of charge at STP, the volume of gas evolved is called as equivalent volume. That is VE. I is current, T is time, V is equivalent to volume divided by 96,500 will give you the volume of the gas evolved at STP. Next, this we learned quantitative aspects of electrolysis. We know that 1 Faraday of electricity is equal to charge carried by 1 mole of an electron. So in any reaction, if 1 mole of electrons are involved, then the reaction would consume or produce 1 Faraday electricity. Since 1 Faraday is equal to 96,500 coulombs, hence 96,500 coulombs of electricity would cause a reaction involving 1 mole of electrons. So all this is fine. You remember this formula, charge Q is equal to I into T, likewise Q is equal to N into F. N is number of moles. A number of moles of electrons, F is Faraday, N into 96,500 coulomb. Thus, the amount of electricity involved in any reaction is related to the number of moles of electrons involved in the reaction, the amount of any substance involved in the reaction. Therefore, 1 Faraday or 96,500 coulomb is equal to 1 mole of electron. This will reduce 1 mole of monovalent cation, half a mole of divalent 1/3 of trivalent, 1 by nth of n valent. Please explain this to me. Read that statement and explain it to me. We learned it. Sodium. Now sodium is monovalent. Na plus. Sodium is monovalent. So in order to reduce sodium, how many moles of electron is required? 1 mole of electron. So 1 mole of electron for one monovalent cation. Now if you take zinc or copper, we learned copper 2 plus. 1 mole of copper 2 plus ions requires 2 moles of electron to reduce it to copper. That means half a mole of divalent cation will be reduced by 1 Faraday current. Here it is 2 moles. 2 moles means what? 2 Faraday current. So 1 mole, if you take, the amount of copper deposited or reduced will be what? Half a mole. Did you understand this part?
Yes, sir.
Others? Divya? All right. If you take aluminium, Al3 plus, this requires 3 moles of electrons. 1 mole of aluminium ion requires 3 moles of electrons. That means 3 Faraday current. So if we pass only 1 Faraday current, how much of aluminium will be reduced? It will be 1 into 1 divided by 3. That is nothing but what? 1 by 3. See here. 1 by 3 mole of trivalent ion. That's what it means. So 1 Faraday current will reduce 1 mole of the trivalent cation. Understood this?
Yes, sir.
Understood or not? Where? Only you are there. Dhanlakshmi is not there.
Sir, I'm there, sir.
Okay. Did you understand the problem, previous problem?
Yes, sir.
Yeah. Now we'll finish up with this. Conductors are 2 types, metallic conductor and electrolytic conductor. In this chapter, we will talk about only electrolytic conductor, but you should know the difference between metallic conductor and electrolytic conductor. In metallic conductor, the charge carrier is electron. The movement of electron in metals will carry current. So in copper wire, aluminum wire, due to the flow of electrons, electricity is conducted. So in any metal, the charge carrier is due to the flow of electrons. But in electrolytic conductors, it's due to the movement of ions, flow of ions towards cathode and anode. We learned it. So ions are charge carriers in electrolytic conduction. So in metallic conductor, it's not accompanied by decomposition. When you're passing current through copper wire or aluminum wire or any other wire, is that metal copper getting decomposed? At home, when you're switching on the light, is the wire getting decomposed?
No, sir.
No. But in case of electrolyte, what happens? Decomposition will take place. Electrolysis principle itself is what? Decomposition of an electrolyte by passing current. So in electrolytic conductor, there will be decomposition of electrolytes. Second difference. Now, in case of metallic conductor, there is no transfer of matter. The matter will not get transferred. Matter does not get transferred. But in case of electrolytic conductor, we learned metals will move towards positive charge, will move towards cathode, negative charge will move towards anode. That means the movement of matter is there. Transfer of matter is involved in electrolytic conduction. And in case of metallic conductor, conductivity decreases with increase in temperature. Remember, as the temperatures increase in metals, resistivity also will increase. Therefore, conductivity will decrease. But here, in case of electrolytic conductor, conductivity will increase with increase in temperature. All right. These are the difference between metallic conductor and the electrolytic conductor. You should remember, in metallic conductor, charge carriers electrons. Here, the charge carrier is ions. All right. Here, decomposition will take place in metal. No decomposition will take place in metal. Here, decomposition will be there in electrolytes. And no matter transfer will be in metals, and in electrolytic metal transfer will be there. Likewise, conductivity decreases on increasing the temperature. In case of electrolytic conductor, conductivity will increase on increase in temperature. The electrolyte may therefore be defined as a substance whose aqueous solution of fused state conduct electricity accompanied by chemical decomposition. The conduction of current through electrolyte is due to movement of ions. We learned it. On the contrary, substance which in the in the form of their solutions or in molten state, do not conduct electricity, are called as non-electrolytes. We learned about electrolytes and non-electrolytes in the previous chapter. The next topic is electrolytic conduction. All right, this electrolytic conduction, resistance, all this is a long part of the topic. So if I start that, we will not be in a position to complete. We will do that on Friday. All right, I will stop class for now. Is it okay?
Yes, sir.
I'll stop the class, ma'am.
Okay, sir. Thank you, sir.
Yeah, ma'am.
Thank you, sir.
Yeah, ma'am.
Thank you,
Bye,
sir.
bye. Bye, bye, bye.